Our next speaker is Jessica Brooks, who works in our Office of Watersheds. And it says here in this little bio here that she has been with the Water Department since January 2007, which can't seem possible because she seems like she's always been there. And she's become a real vital part of our organization. She's an engineer. She got a BS in engineering from the University of Pennsylvania, the Master's of Science in Environmental Engineering from Northeastern University. And she worked in the private sector for a while and came and is now working with us and is one of our stormwater low-impact development experts. So with that, I'd like to invite Jessica.
You know, it seems like I haven't been at the water department that long, but I came at the right time. That's what I like to think. Right when we're starting to do some really exciting work. We're talking about green streets, and we're talking about green streets down on the block scale here. It's really getting into the nitty-gritty of how do you do this when you enter into a neighborhood, dealing with all of those issues that we've talked about in terms of getting a design that works in the street and it works with all the other uses of the street. We're presenting, like I said, I thought I was going first, West Mill Creek, which was already presented, and Baltimore Avenue. I'm also going to do the Waterview Recreation Center and Columbus Square Park. Like I said, the designing in the right-of-way, it's a tricky site. There are just a number of uses. We've been going over this all day, basically. There are so many different people that use it. There are different utilities that use it. We've got bikers. We need to accommodate pedestrians. We need to accommodate just everything that's going on there in the street. They're busy places and they're hard places to do these kinds of designs. But the goal really is to enhance all of these uses through greening and also to improve, for the water department, the stormwater characteristics of the street. So those are really the focuses when we're going into design on a block. How do we, maintain all the existing uses, enhance them, and then also get some benefit for the stormwater management? There's a number of approaches. These are, again, things that we've been talking about all day. Tree trenches and tree pits, sidewalk planters, curb extensions and bump outs, porous paving, swales, vegetated medians. Basically, you need to look at your street and look at what makes sense on your street. Sometimes you're going to be able to have the sidewalk width available to you to be able to put in a planter. Sometimes you're not. Sometimes, traffic calming is going to be what's more important to you there. Sometimes you're just going to need to get the shading, so you want the tree trench. There are a mix of things here, and what we're working towards right now is being able to have designs for each of these, being able to have that in our toolbox and go to a street and apply those designs very quickly and efficiently. To that end, we're doing a number of pilot projects, and these are some of the concepts, just to look at the pretty pictures, because I'm going to get into some details that aren't pretty. This is a sidewalk planter, and then the kind of bump out design. But what we're doing in the city right now are a number of pilot projects so that we can test these out, see what works, see what doesn't work, see what doesn't work, and really be able to move forward with the designs that are able to apply to different scenarios. First, we're going to talk about Waterview Recreation Center. It's come up a number of times today in the presentations. I think it's because we're very proud of this site. We're very proud of the different kind of designs that we were able to put in place here and the accomplishments that we had. It's really a great site. It's a great old building. It's so cool. And it really had a really large, wide open sidewalk, no shade, just not the best face for one of our city's recreation centers for such a great old building. It's located in the Germantown neighborhood in Philadelphia, for those of you who know the neighborhoods. It's in the TTF, and the sewer shed is combined there. One of the things that's come across today is, at least within Philadelphia, our programs are aiming at reducing our combined sewer overflows. So a lot of times when we can get these projects into combined sewer sheds, that's really great. As a design goal for our street projects, we take the lead from our own Philadelphia stormwater management regulations. We have pretty stringent regulations in the city, and the main goal of those is to manage that first inch of runoff from any of the impervious contributing area. So in this case, we've got a little over 12,000 square feet of street and sidewalk. We were also able to manage about 1,000 square feet of roof runoff. And we did that through 3 different systems. We're using infiltration tree trenches, porous concrete sidewalks, and also flow-through planter boxes for the building. So I'm going to go through these designs. As you can see, at the face of the, is there? Oh, the pointer's gone. So you can see just kind of the face of the building, there's quite a bit of room there, and we're taking the sidewalk. You see the sort of before and after on that sidewalk. It does get more narrow, but we're still meeting all pedestrian requirements for the width of that sidewalk. And I'm going to get a little closer so we can see the design here is 2 tree infiltration trenches on either side of the front of that building. These tree trenches are fronted by about 310 feet of porous pavement or porous concrete sidewalk. And we also have 2, thank you, flow-through planter boxes. So I'll point them out a little bit here. So you can see these are the tree trenches on either side. This whole area in front of the building is going to be porous concrete sidewalk. And then we've got the 2 flow-through planter boxes that are coming off the roof leaders of the building. And one of the interesting things, I'm going to point this out right now while it's laid out, where you can see it here, and it'll be obvious when I go through some of the details later. We've got storage areas here, these darker areas. That's the additional storage for the volume that's coming in. It's underneath the concrete sidewalk. While in the center, because we're in front of the building, we didn't want to concentrate stormwater right next to that basement. So that's actually just got the 8 inches of stone, while the area in front of the tree has 2 feet of stone. Well, where we could manage 2 feet of stone. As Michelle mentioned earlier, we did hit some bedrock, so we had to adjust some of that, exactly where that storage went, but we did still get it all. So this is just a cut through of that system there. You can see what's going on here is we have inlets that are going in the street here. Those inlets feed this system where there's 2 feet of stone underneath the sidewalk. And that's the bulk of the storage. That's what's going to hold the water during the storm and then slowly infiltrate it into the ground afterwards. And we also have a drip line running along the tree lawn. And I actually thought this was a really elegant solution because a lot of times, West Mill Creek is a great project, and it was one of our first projects, but when you put the tree in all of that gravel right next to it, it's really on 3 sides gravel. I get a little concerned about the health of the tree. They've been doing fine, so maybe I don't need to be so concerned. But I think this system actually does a really nice job of addressing both the storage requirements and going through with the trees. And as Michelle also mentioned earlier, they did have to switch this up really quickly at the end. They did have the trees originally in the front and storage between the trees, so I think they given the constraints of the site, they did a great job. So you can see here, like I mentioned earlier, we had a little over 12,000 square feet of drainage area. The storage volume is sufficient to capture the first inch of runoff, and really that does not take into account infiltration during the storm, although we did go out and measure infiltration rates, and we had really quite nice rates where there wasn't bedrock, about 4.5 inches per hour. And the disconnected area I'm saying there, that's that area that is sidewalk but not additional storage under there because of the building. So porous concrete. This is the first time in Philadelphia we've put porous concrete in the right-of-way. It was an exciting process. It's a very different process than pouring regular concrete. There were a number of bumps, but I think we learned quite a bit, and we're ready to know what we need to change as we move forward. As you can see here, just for those of you who know how concrete goes in, you may not, this is really different. It's a much chunkier material. There was a video playing during lunch you may have seen where they kind of explained how the mix can't be too dry, it can't be too wet. One of the important features about putting down porous concrete is being able to cover it very quickly so it doesn't dry too fast. And then there's a bit of hand tooling involved, getting those edges cleaned up. There are a number of ways that you can go about doing some of these things. But I think in the end it gives a nice look. As Darren mentioned that, people do, you either love it or hate it. It definitely is chunkier. This mix design was a little different than what we originally spec'd. That originally spec'd actually a mix that had some more fine material. You give up a little bit of porosity when you go that route, but we were hoping to get a smoother look. What we found, though, was that for a job this size, because it's not a standard practice in Philadelphia, the contractor simply, the supplier just didn't want to make that mix just for us. So we went with the 3/8 inch stone, which is a standard. It's not that it was bad to put it in that way, but we were hoping to try and test out something a little finer mix, but you know, there's always the next project. So you can see why some people feel like when you get up close, it looks quite a bit different. But when you look at, I think, when you look at the landscape, it's just great. I'm going to talk about the flow-through planter boxes a little bit. I think flow-through planter boxes are a great solution for small areas next to buildings when you're a little concerned about putting water next to an old foundation. And in this case, the building actually was ideally set up for it because it actually has external roof leaders to begin with. Doesn't happen that much in Philadelphia. So we were able to just cut right into those roof leaders and take that stormwater into a planter box before sending it back to the existing drainage. So this is during construction a little bit. You can see this down here is actually the drain, the overflow. What happens is the water comes into the planter, fills up the planter. There's an under drain there that is connected back into the existing leader. And so this doesn't infiltrate, it is solid, but that's why it's safe to put next to the building. So for you guys over here, this is your drain, your new drain that comes back into the system. The roof leader comes down, it's disconnected at this point, water flows into the planter, and then it drains back into the system. But it really slows it down, even though this volume isn't removed, it's much slower and it's also feeding that greening. I'm going to touch very briefly on maintenance, but don't be misled, maintenance is not a brief issue. It's a really big issue for us. In just this project, we're going to need to be focused on inlet cleaning. Those inlets do feed our infiltration system. They are effectively our only pre-treatment, which means we need to pay attention to them, because if we allow too much debris to get through those inlets, our infiltration is going to be degraded by that. Vacuuming the concrete. This is tricky for us. Right now we don't sweep our streets. We certainly don't vacuum our sidewalks. But you can see in this picture, well, maybe you can't. If you look really closely, you can see that we're already getting a little bit of leaf debris that's breaking down and going into these pores. We don't know right now how long it's going to take to clog that. One of the great things about porous concrete is that it's incredibly porous. So we have probably a lot of leeway here, but you don't want to push it too far. I mean, the point of the project is that it works, continues to work, but we do need to oversee that. We got to monitor drain down time. This is just making sure that the system continues to function, that the infiltration is still working, that we haven't clogged our stone bed, we haven't clogged our pipes, and then maintaining vegetation. That's always an effort. It's a particularly difficult effort for those of us at the water department. It's not something we've ever done before, but as we take on these planters and these greening efforts as our infrastructure, it's certainly something we need to address. I'm going to move on to Columbus Square now. This is another recreation center. Maybe you've noticed we target those. But this is actually in South Philadelphia. It's bordered by 12th and 12th Street, Wharton, 13th, and Reed. For those and I think I have it here too. Yeah, so you can see it's in South Philadelphia. It's in the Delaware watershed. And again, we're in a combined sewer shed. One of the efforts, it was sort of, South Philadelphia. Yeah. I don't know if you guys heard, South Philadelphia floods sometimes. It's a problem. So we often target our projects in combined sewer sheds for the CSO benefit. We also are targeting projects in South Philadelphia and other flooding areas because we know that we have a specific capacity issue there. As you can see, it's not the only project we're doing in South Philadelphia. So we definitely are focusing our efforts at times like that. We actually have a phase 1 and a phase 2 for Columbus Square Park. At this point, we're not finished with the design. We're certainly not constructed on either of these phases, but I think thought it was a good one to present because we're getting pretty close, and it's been a really interesting process. Phase 1 is some stormwater planters. They're going in the sidewalks, and then we also are looking for we're going to do a Raingarden project, which is again going to take street runoff. When we first approached this site, we sort of thought, well, there's no obvious spot to put the stormwater here. You know, at Waterview, there was obviously a large building with an entrance that we wanted to enhance. We had 4 blocks that we could think about, and this is what happens when you go to do a design on a site like this. You've got to take into account, you know, you have a limited budget, you want to get your most effectiveness out of it. Where are you going to put your stormwater? So we looked at Wharton Street. Well, Wharton Street is heavily shaded. There's an existing tree lawn and just behind the sidewalk, a lot of shade, and it had utility conflicts under the sidewalk. 12th Street looked ideal to begin with, but then we realized, you know, actually it's new sidewalk, so we don't want to go in just constructed, go back in and disrupt that. So there's new trees there. They're about a year old. Probably any construction we would do would kill these trees. That's not our goal. And there are utility poles, which are always just an added effort of working around. Reed Street, again, there were existing trees there. That was really the best reason for staying out of there. And then 13th Street, there are very few trees. There are no utility conflicts. And you can see it's just a wide open street, or sidewalk. We had a lot of room here to work with. It's about a 12-foot sidewalk, and then there's a lot of back area there. So that's why we originally came up with this concept design of putting about 6 planters down along 13th Street. They would be managing the first inch again. This is just another look at those planters. You guys have seen this before all day today. There are these Portland planters where we're talking about having parking next to them, a step-off area for getting out of your car, but then also maintaining that travel path in the back for pedestrians. There they are, in Portland. Someday they'll be here. Tricks always come up. We went out onto the site. We had a design where we were going to do infiltration. That's always our first approach. If we can infiltrate that water, completely remove it from our system, that's the best. Unfortunately, we went out, we did Philip Dunn permeameter tests, and we also did quite a lot of soil tests because we are putting planters in here. We wanted to know, can we use any of the existing soil? Is that possible? Or do we need to bring in all new soil? I mean, ideally we'd be able to use the soil on the site. It's less construction waste, it's less cost, but you know, these are streets. It may not be the best soil to plant things in. So we really did a number of tests on this soil. Just, you know, it's kind of crazy there, but you just look at that range there, and it's really to figure out, you know, what the plants need, do we have it, how much do we need to amend it. But yeah, we didn't have any infiltration. We put the water down there, we came back a day later, the water was still there. So we realized that we cannot infiltrate on this site. That's okay. We have other ways of dealing with stormwater. Since we're in a combined sewer shed, that means that we're going to retain that water on site and slowly release it back into the system. We really want to, you know, break up the peaks of these storms so that our system in the street can manage it. And you know, we definitely are still going to get some volume removal here as long as we have a vegetated system. It's not, you don't want to forget that part of it. We're still getting benefit. We're still getting removal because we are going the vegetated route. Now, if this was just a box that held the water, that may not be true. But in this case, you know, it's a benefit we don't put into our calculations as engineers, but it's there. And again, it's that 1 inch. This detail is just kind of showing a system where you can put in the planters. You've got storage underneath the planters, and those are underdrained back into the combined sewer system. And in our case, we're going to have a control structure, which is the smaller detail here. It has just a very small orifice to really hold that water back in the system and slowly release it. The drainage area in Columbus Square, again, we're getting street and road runoff. It's about 8,000 square feet. You can see that there. So we're doing 2 sidewalk planters that are draining to the inlet. We've taken out the sidewalk planters that were in the center of the street. That's basically a cost issue for us. We have to underdrain these systems, and to put an underdrain from the center of the street all the way out to the edge of the street where we have infrastructure, it's very expensive. So it just changes the way we locate our projects once you're realizing that there are some additional constraints on it. We also at this point, the spacing is driven by that storage volume that we need in order to be able to release that water back into our system slowly. Okay, so like I said before, there are a number of things that we had to deal with here once we're actually putting in the planters on the surface. Beyond the stormwater management, we have to meet all of the other needs of this street. So we need to allow for parking, we need to allow for pedestrians, and a couple of things we did in that effort were to, obviously meet ADA requirements for spacing, have all the travel paths be ADA, size for ADA, and then also we put landscape buffers on either end, so you're less likely to walk into the planter. There's also a curb around them, so you can't just walk into them, but it's just a visual barrier there between the pedestrian and the planter itself. We went through a lot of conversations with the streets department to make sure that we're meeting all the requirements of step-off zones, what size you need here, what size of sidewalk, and really in this case they had some really great input. For example, we came to them and said, well, we're going to have 5 feet of sidewalk behind the planter. That's the minimum required by ADA, so we just assumed it was fine. They said, well, this is actually it's next to a park. You're going to have a lot of kids on bikes. You're going to have more sidewalk requirement than you necessarily do in other streets, so why don't we go to 6? So we go to 6. Another thing that happened was the step-off area. Their minimum there was 18 inches to be able to get out of your car, but talking to the community, there's a big concern about that accessibility, so we're going to widen that a little bit. These obviously are not ideal for the planter itself because we want to maximize that planted area. But sometimes you have to make concessions in order to make sure that the community can actually have a livable street. This is just a prettier picture of a planter, really. Should have gone to it earlier. But this is from the Pennsylvania Horticultural Society, as mentioned earlier. Actually did a project where they went out and asked horticulturists, what are you going to plant in these? Because that's a big part of this. These plants need to live. And this is not an easy place for a plant to live. It's got to have salt, it's going to have cinders, it's going to have wet, it's going to have dry, it's tough. So they went out and said, what plants do you want to put in here in order to be able to have a really thriving palette? And we had some great responses on it. We really appreciate it. We're definitely going to test some out on this site. So I mentioned these are pilot projects for the water department. There are a couple of things that are very specifically getting tested out on this site. One of those is those planters that I was talking about. We're also using 2 different versions of inlets into the planters. So Chris mentioned earlier, if the water doesn't get into your planter, why did you put the planter there? So in order to really look at this and address it, we're doing 2 different styles of inlets. We're doing one inlet that is really just a trench drain across the sidewalk. It's slightly sumped in turn to collect a little bit of sediment and things to keep it out of the planter, but that's really just a curb opening on the street that's collecting the water. And the other design, it's a bit more structural, probably more expensive, but maybe more functional and maybe what's necessary. We're actually putting an inlet in the street. So that's this one here that then brings the water in through that and kind of curves back up. It's an interesting design. So we're doing two different styles there to make sure that we end up with one that works well. We're also testing out some of those planter palettes that the Horticultural Society was able to bring together, which is the fun part of my presentation. I'll just let you look at pretty pictures for a while. But you can see really, these are really creative, not just looking at what's sturdy, but what's going to be beautiful and make a great sidewalk. So a couple, probably two or three of these will go in at Columbus Square. Okay, so again, maintenance, it's always an issue. Again, we have inlet cleaning. That's an obvious need for any of these projects that have a sumped area especially. In this particular project, we will also have that low flow orifice. It's going to be a very small hole, and it's going to be really easy for that to clog. So we need to make sure it's well protected in our design, and we also need to make sure that we're monitoring it and making sure that it is clean all the time. And then obviously maintaining the vegetation. Again, this is a big challenge for those of us at the water department. It's not what we're used to doing. Pipes, fine. Vegetation, it's new to us. And you can see vegetation. This is actually a picture from Columbus Square. They already have a pseudo planter. It's just not collecting rainwater, unfortunately. I kind of like this, but that's me. I can see why some people don't. So there are definitely, vegetation can get out of control, and we need to make sure that it's doing well. Phase 2, this is actually my only slide on Phase 2. That's how conceptual it is at this point. We want to put in a rain garden. There are really these wide open entrances at a couple spots at this park. This is actually a low point on 2 corners. It's at 12th and Reed, and it will collect water from both 12th and Reed Street into one system without crossing the street. It's very cool. So we're hoping really to kind of go into this central area here, so we can even maintain the 12-foot sidewalk in this case, but have quite a bit of room in this area to be doing some planting and all that. So that's kind of coming up. I want to say before I go, this is my last slide, but I want to say before I go, it's one of the best things really of doing these projects are the people that we get to work with. We have so many partners from the water department, just so many partners that are making this possible. These specific projects were really done through help with Meliora Environmental Design. They did the designs for Waterview. Camp Dresser McKee, CDM, they did the designs for Columbus Square. Dan Meier presented earlier, doing designs for Baltimore Street, Baltimore Ave, and West Mill Creek. And as always, our work with Horticultural Society. It's just been really great. It's really fun. I guess that's it.